Hi there, my name is Mitch Karlabidis, and in this video we will work together some examples in where we are asked to determine the equation of a line under certain given info. Let's start, for instance, with exercise 22. We need to determine the equation of a line that passes through the point, -2 and 3, and is perpendicular to another line. Okay, so to make things easy, we should name them. So, equation of a line, let's call L1. I'll call L1 the equation I am looking for. Every single exercise in which we are asked to determine the equation of a line should start from us trying to find the equation of the line at its slope-intercept form. So L1, so far, it should be y equals m of L1 times x plus c, where m of L1 is the slope of L1. Now, let's see. What do we know? We know that L1 should be passing through this point, -2 and 3. What else do we know? We know that L1 is also perpendicular to y equals 23x minus 4. Let's call that L2. 23x minus 4. Why is that? If I want to find the equation of the line 1 in slope-intercept form, all I have to do is determine these two values, slope and c. And we always begin with the slope. The slope of L1. It would be easy if I knew 2 points of that. So I could have applied the slope-intercept formula. But now I don't have 2 points, I simply have 1. But I was given an extra condition. I know that since L1 is perpendicular to L2, their slopes should be negative reciprocals. This means that if we multiply their slopes, we would get -1. I know the slope of L2, that it is equal to 23. How do I know that? Well, L2 is already expressed in slope-intercept form. I can see that the coefficient of x is 23. That's what the slope is. So the slope of L2 is 23, which means that the slope of L1 should be the negative reciprocal of that number. And by negative reciprocal, remember, it means flip them. So from 23, which is the same as 23 over 1, make it 1 over 23, and since we want them to be negative reciprocals, put a minus in front. Change the sign as well. So this means that so far, the L1 would be y equals -1 over 23x plus c. How can I find the value of c? We need to apply 1 point and remember that point with regards to a line's point. That poem would go as follows. A point lies on a line when its coordinates satisfy the line's equation. Do we have a point on that line? Yes, it's point -2 and 3. This is the x-coordinate, this is the y-coordinate. Since this point does lie on that line, it means that if I properly substitute -2 instead of x, 3 instead of y, a true statement will be produced. So 3 equals -1 over 23 times -2 plus c. So 3 is 2 over 23 plus c, which means that 3 minus 2 over 23 equals c, which means that 67 over 23 equals c. So finally, L1 should be minus 1 over 23x plus 67 over 23. Am I done? No, because the exercise needed the standard form. The standard form is the form which can be taken if we bring x's and y's on the same side. So 1 over 23x plus y equals 67 over 23. Am I done? No, because in the standard form, we need these numbers to be integers, whole ones. So to do so, we should multiply by the LCM everything. So 23 over 1 times 1 over 23x plus 23 times y equals 23 times 67 over 23. These are cancelled out, and we end up with x plus 23y equals 67, which is the answer. Let's go to 27. Again, we need write the equation of a line. So let's call that L1. So I'm gonna write again that let L1 be the line I need to find. What do I know about this? The given is that L1 passes through point -1, 4, and is parallel to this. Let's call this L2. Sorry. L1 is parallel to L2, which is the line minus 3x plus 2. We need to find again the equation of L1 in standard form. As always, however, we should begin with, excuse me, with the slope-intercept form. So the slope-intercept form of L1 should be m of L1, the slope of it, times x, plus c. The first thing to do would be to calculate the slope. It would be easy if I knew 2 points, which I don't, but we were given a key condition. We were told that L1 is parallel to L2. Now we have to recall, what does that mean? Two lines are parallel when they have equal slopes. So this means that the slope of L1 is equal to the slope of L2. Do we know anything about the slope of L2? We know that L2 is the one with equation minus 3x plus 2. Since this, however, is a slope-intercept form, we know that in a slope-intercept form, the slope is given directly as the coefficient of x. So this is a slope here, which is -3, which means that the slope of L2 is -3. And once again, since L1 and L2 are parallel, they have the same slope. So the slope of L1 will be as well equal to -3, which means that so far L1 should be y equals minus 3x plus c. Now, we need to find the value of c. How? We will use a point, the point -1 and 4. We know that this point passes through, this point is on line L1. L1 passes through this point. So the coordinates of that point, -1 and 4, if properly substituted in places of x and y, they will produce a true statement, which means that for x equals -1 and y equals 4, the y equals -3x plus c will become 4 equals -3 times -1 plus c, So 4 is 3 plus c. 4 minus 3 is c. c is 1. So finally, L1 will have the slope-intercept form of minus 3x plus 1. Am I done? No, because the exercise wanted the standard form. Okay, the standard form is the form in which x's and y's are brought on one side. So this means that it should be 3x plus y equals 1. X's and y's are brought on the same side. All coefficients 3, 1, and 1 are whole numbers, are integers, so I'm done. This is the standard form. And that would be it. You see that in these exercises, all we do is try to see how we can use the given info and utilize all theory we know. Remember that key words as parallel, perpendicular refer to slopes. Remember also that whenever we want to find any form of a line, we should always begin by the slope-intercept form, and then everything else it's about practice and operations. In case you have any difficulties on that, in case you do have any concerns, please share them with me as a comment below the video. As always, thank you for your time.